Hi everybody, this is an instructional video how to build my Dazatronyx THD. I've released this as a public circuit board so you can build one yourself. Just as a bit of background, the first board looks something like this. And as you can see, that's not an easy board. There's a lot of room for human error, getting the parts wrong, short circuits on the back. Just the density of the parts is really close, so and there's a lot of hardware mounted, so there's a lot of room for error. You have to drill in a lot of parts, really dense. But in contrast, if you look at these new ones, all you have to do is put in these audio capacitors, and they're fairly well spaced apart. Like on the back, the pads are really far apart, most of them, so you're not going to have short circuits. And the amount of connections you have to the hardware is a real minimum. You don't even have to cut and insulate wires or anything, so it saves time. It's easy. The foot switch wiring is sort of pre-drawn for you. Just copy what's happening in the diagram. You don't have to understand what's happening, you just have to pretty much copy it across. So it's fairly mindless. I know a lot of people don't really want to have to work out wiring and schematics, and it's an entry-level sort of circuit board that you can just jump straight into it, I think. Alright, I'm gonna get straight into it myself, yeah. Because like I said, we're gonna go from beginning to end, so this might go a while. Strap in, let's get going. I'll try and punch through it. So basically I'm just gonna start with this board by putting in all the parts from bottom up, and like I said, there's not many parts. First thing I might do is snap these edges off, these railings. So this will come to you in the post in a letter, I'd say, and we don't need them anymore. If there's anything on the side, it might be a good time to, you don't have to, but you get a razor blade or some sandpaper, or yeah. So this video won't show you how to do the box, because that feels like that's a video in itself or several. But basically, if you get the drill template off my website and print it 1:1 scale, so don't scale it up to fit, and then you'll have to measure it with a ruler or something like that and scale it correctly, because most home printers actually might have like a 2% margin of error. People don't notice or care. And then when you cut them out, you wrap it around the box, you put the holes in the right spot, basically. But yeah, that's another video. I'm gonna assume that you have a box. So I'm gonna build this one today. Hopefully you can see that. So I'm gonna start with the diodes. It's calling for 2 germanium diodes. I've got these. I'm just bending the legs down. There's a polarity symbol on that, so I'm putting that at the top. If you can't find germanium, you could also use a Schottky diode, or you could put a jumper across one of those, but a germanium diode would do the job the best. Now, as for the polarity, the square pad will be the negative lead on your diode. If your diode won't have a symbol like mine, it might have a black band on one side. The side with the band is the negative side, but it actually doesn't matter because these are clipping diodes, so as long as you have them in opposite directions, it doesn't matter if you put them in backwards. As long as they're both in backwards is what I would mean. Okay, so moving up, I'm just going to go through the capacitors from top to bottom. And what I'm going to do is put all the parts in and then solder them at the end. If you want, you can put them one at a time, solder them one at a time. But because they're fairly spaced apart, I feel like I've got enough room to get the iron everywhere. And if you made a mistake, you could just swap the parts without having to desolder anything. So the first capacitor is a 1 nanofarad, which is 0.001 microfarads. And I've put the capacitor numbers here. It says 102. So it's good to just double check as you go if they have that number on them. And this is going into C16. Now these markings, I know they're really tiny, but that's really important because it makes it look sexy when you're done covering them all up, and that's important to me. So what you can do, you can print it up if you can't see. Like I can see, but I know a lot of people can't see very well for things that small. So you can print a large version or just get it on your mobile phone and, you know, pinch to zoom in on the PDF, which is on my website at the time of this video. C16, that's this one here. Now you'll notice I've put in 2 holes for C16 on one side. A couple of the capacitors are like that. That gives you option 4. Let me show you. So I could have also used something like, well, if this still had some legs on it, these have a smaller pitch width. You could have also used an MKT, these box capacitors, they work really well too. So if you can't get these green caps or you want to use something else, get some MKT box capacitors. So again, that's another thing that makes this board simple. You can use a lot of parts. So sourcing parts shouldn't be a problem, and they're very common values. All right, 1 nanofarad into C16. What I'm going to do is just bend the legs a little bit on the reverse side so it's supported, same as I've done with the diodes. This way I don't need any tools or jigs or anything. Okay, I'm going to cross that off because I feel like a lot of people do that. Maybe a pen that doesn't mark the whole thing out would be nicer. Yeah, there's a smaller pen. 4N7 is the next one up, which is 4.7 nanofarads or 0.0047 microfarads. Don't mix it up with the 47 nanofarad, which is obviously larger. Goes into C26. Let me look. Okay, C26 is in the middle here. So these boards have the part number and the part value marked. So that's a way of double checking your work. And then triple check 472, 472, that's correct. I'm centering it so it looks pretty, and spread the legs. Next one up, C27, 6N8, 6.8 nanofarads. So I can see that one's up here in the top left. I've got to make sure I get the right pads. These are not the right pads for me. I'm using the small one. But sometimes the manufacturer might issue 5mm spaced pads, and I buy them instead, depending what's available. Okay, 547 nanofarads into 1691122. Again, check the numbers, 473, 473. C1 down the bottom left. C6 also down the bottom left. C9 is in the top left. Again, check the values and the part numbers as you put them in. C11 is down in the middle on the left. And C22 is about in the middle of the board. You might notice this board doesn't have any electrolytic capacitors. Instead, what I've done is I've put these banks of multi-layer ceramic capacitors everywhere. So pretty much every chip gets at least 2 capacitors to its own. These are low ESR capacitors, so like low internal resistance. They can discharge quickly. They're good for high frequencies, but they'll also have a really long shelf life. So this board can now outlive a human probably. And it saves you putting in capacitors backwards, and it also spreads it around the board rather than just having one giant capacitor in the middle that everything's sharing off and sharing the same ripple from. Okay, 47 nanos are done. 68 nano into C30. Again, make sure you don't mix it up with the 6.8 nanofarads. C30 I can see in the top right here. There's a reason why I'm spreading the legs like this. 100 nanofarads into C28, C29. So C28 in the top left. And C29 beside it. Then we've got these 1 microfarad capacitors. Again, you might not be able to find these, so you can use a 1 microfarad box capacitor, and MKT would do the same thing. 12, 15, 34, so basically whatever's left. 12 in the middle. 15 over here on the right, and 34 above that. Alright, I'm going to start soldering these. I'm just going to turn the iron on. There is a resistor here, which I'm not using, which is for the LED. So let me tell you what's happening with this. This LED only needs a 33k resistor because it's a high intensity, ultra bright. It needs almost nothing to turn it on. So I've already put in a 33k. But if you're using an LED like this, it probably needs about 1k. Or if you're using a regular intensity clear LED, it probably needs about 10k. So you'd put that resistor in here. I'm going to turn on my extractor fan. What you'll find is usually when people solder, they have a habit of blowing the fumes just as they make contact, so it gets the smoke away from your face. As long as you're not in an exposed area, like a lot of people won't use an extractor when you're beginning, just get it out of your face, stop it from landing in your eyes, and wash your hands before eating. Don't pick your nose. Someone told me that and I thought about it. That makes sense. I'm using unleaded solder because I don't believe in using lead. Not to get preachy, but why would you? And I'm just systematically making my way through. These ones where there's 2 holes, if you accidentally fill in the second hole, don't worry about it. That's perfectly okay. It's almost an upgrade. Now this isn't a soldering lesson, but I'm holding the iron just for a moment. Watch the blob go through because I want it to come through both sides. Do your best. We can't ask any more than that. Okay, so I'm going to cut off all the legs that are left, and some of them I'm going to save. The ones that are uniform and similar, so these orange caps, I'm going to separate them first, and the diodes I don't want. They're very old, oxidized, new old stock vintage ones. These legs though, we've kept them straight. I'm going to recycle them. Which is another feature of this circuit board in cutting down cost, complexity. Less is more, no part is the best part, that sort of thing. Now put these aside, don't throw them out, like I said. So yeah, I didn't mark these off, obviously. Done, done, done. Done. LED, I'll put that in soon. So all the parts are added to the board now, and it's looking pretty much like the finished one. So we have to start putting in the connections to go to all the hardware, and then after that, the connections to go to the foot switch, and we'll start wiring it all up. So this is where I'm going to recycle these clippings from before. So there's 5 pads at the top, and they're each going to need a wire. So get the longest ones you can find, because these are going to connect to the audio jacks. Now my trick for this is just to overhang the solder off the edge of the desk. My fingers are pretty tough, so I don't mind the heat. I would like it to come through both sides now if possible, but if not, I'll... Yep, it is good. Okay, the top ones are done. So let's take a look at the foot switch wiring. It's probably the messiest part of the pedal. As you can see, there's a link from every pad to the switch, except for this one here, which is out, which is a wire going to the center terminal. So let's chuck those wires in. And remember, don't put one into the out pad. You don't have to use all of them. If one's got like a solder blob, might as well just throw it aside. There's a few leftovers. Okay, so the only one left is that out. I'm going to use a wire. I'm sure you have some wire lying around. You can use it cutting off a battery snap or something. And I need about 25 millimeters. What's that, about an inch-ish? I'm stripping about 2 millimeters of insulation off each end. And then I'm going to pre-tin one or both sides. Depends. Usually I don't tin the one that's going in the PCB because my wire is really stiff and it won't fray apart, but you might have to if you've got like your wire feels like the strands might spread apart, so I'll give it a twist and pre-tin it. Okay, that's done. Now there was an LED missing. That can go in the board now. So the polarity on the LED, the short leg is the negative side that goes into the square pad. Same as a diode, I mean it is a diode, so same as power and clipping diodes, the negative will be the square pad. So I'm just going to spread them apart a little bit so it's going to stay in the board. I'm keeping the legs straight. I'm not going to bother with insulation or anything because it's not going very far. Now, sort of idiot check your board, and if there's anything sticking up extra high, make sure it's cut low because the potentiometers are going to go over this and you don't want them shorting out to the casings of the pots. And give it a good looking over. You could take a photo with your mobile phone now from a few different angles, so if you have any issues and you have to debug later, you can look over it and zoom in on your phone, under good lighting of course if you can. Take it outside maybe, or under a lamp. Okay, I'm going to keep moving on and mount stuff into the box. So here's my box. Speaking about the box, this is a Hammond 1590BS, which is a deeper version of a 1590B. I think it's about 40 millimeters, or exactly 40 millimeters. You could also use a 125B, which is about this big, which I would call the Hammond 1590N1. It's just a little bit bigger around every side. You can get them cheap from Tater and stuff. And it'll just give you more room if you're not comfortable with such a small amount of slack. This is a really tight board, like there's not a millimeter of slack in there. Let's do the foot switch first. I'm going to use a shifting spanner to get the nut off. And put the hardware aside. I'm actually going to put these two nuts back on for my own build and put on a third one. Now from these links, I'm going to use two of them. And from this diagram, see you've got these two jumper links from top left, and they also go to the board. So I'm only going to solder the bottom ends, or solder, however you want to pronounce it in your country. Make sure that the lugs are all straight before you get started. They do bounce around a bit. Okay, from the top left to the middle bottom, check the diagram. I'm going to wrap the bottom one. This is optional. It's just something I'm going to do to make my life easier, but it might make your job trickier. Now I'm only going to solder the bottom one because, like I said, the top one is going to connect to the board, so it's going to have a second connection later. And let's get that second one in from the top to the bottom right, again, just like the diagram. Double check the diagram. Basically what these links are doing is sending the ins to the outs, and they're also using the ground to mute the input of the circuit board in and out. So when you're in bypass, the in and out get grounded, and this helps keep noise low and helps prevent oscillations, particularly with high gain circuits. So yeah, I'm soldering the bottom, but I'm leaving the top. So I'm going to cut the excess length off the tops into my e-waste bin. I'm going to use a dress nut. It's not on the bill of materials. Basically all the hardware here I've said to buy is on my left here. This dress nut's not on the hardware list. You can put on whatever you like. There's lots of options for that. And you can see, because we've done the wiring before it's gone into the box, it's made it that much easier. That would have been a little bit tricky to get to had it been in the box. So I'm holding the switch as I tighten it up. There's no point in holding the box and tightening up because it's just going to turn in place. And I want to get it all straight, obviously. May as well make it look nice. Next thing I'm going to put in is the 2.1mm DC socket. Do double check that there's not a 2.5mm because they look almost identical. So I'll just take a look at this for a second. On this socket, the main thing you need to know is this top one here is positive, and the one that sticks out oddly from the other two is negative in this instance. The third one here that we're not going to use is for switching a battery connector in and out, but like I said, we're not using it. So keeping that in mind, we're only using these two terminals, so I'm going to make sure that they're at the top when I tighten it up so that we can access them easily. See, it's on like maybe at like a 45-degree angle, something like that. There's not much room to get the shifter in, so I have to keep sort of changing. Oh, a little awkward. There we go. That's looking good. Okay, now we're going to speak about these potentiometers, of which there are 4. One of them is a dual gang pot for the distortion. That fixes up the problem where half of the pot range used to be inoperable, sort of. It almost felt like it was broken in the original HM-2. And everyone who clones it, I noticed they keep cloning the same problem. I don't know why no one's fixed that. Well, that I know of. Link me if someone has. So I'm taking all the hardware off, obviously, before it goes in. There's a little indexing tab here. You can snap it off with your pliers. If you are going to use your pliers, do it close to the pivot point so you're not twisting them. Now, on the hardware list, I've said optionally 4 extra pot nuts. Blah, pot nuts. So I have them. 1, 2. Luckily they're sticky so you can pick them up. Why are there 4 extra pot nuts? Because the knobs sit high and they leave a gap, and that's ugly. So rather than cutting the tops off the shafts, or you can't really drill the knob out any further, I'm just going to pack out the inside with an extra nut. I'm using a 10mm socket, but you can use hand tighten or a shifter. And make sure you go all the way down on all of them so that they're consistent. Now if you compare that, it's got a little bit of a gap, but that's a sensible gap. So I'm going to load them up. Take a moment to make sure all the legs are straight. Like I can see these ones are knocked about a bit. Left, right, up, down, all that. You know the axes. Cool, all good. So I'm going to load these in. 10kA is the volume pot, or level I called it on this board. The tone control pots are 5kBs both, and double check as you're going in. I've marked them on the back, 5kB, because you know sometimes you put in pots in the wrong left and right and you don't get it right. It's so frustrating. These ones are from Tato, I don't usually use those. And 100kA as the dual gang distortion pot, it's all labeled. Okay, so what I'm going to do, this is probably a little fiddly, I'm going to use 2 fingers to sort of support. Yeah, you'll work it out. Yeah, so I've got the bottom ones in, I'm using the 2 fingers to guide the top ones in. You might not do it as quick as I have. No, I'm pushing it, it's not going in any further. Give them a jiggle, 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 jiggle. And that's it. That's all in. Put the hardware on. Washers and nuts. I've got a matching one, I'm going to use that. Sometimes the nut might not grab, you might just have to push it from one side. At the back, there we go. Now I'm doing this loosely for now, don't go all the way. I was going to say, if there isn't enough thread to get the nut on because you've put the extra nut on the other side, then you can just omit the washer. You don't really need the washer. So as I tighten up these pots, I'm going to support it with my finger on the opposite side, because as you tighten it, it's going to have a tendency to go clockwise with the nut. And just do it as firm as you feel would be sensible, again without it twisting the pot's position inside. Yep. Now like I said, probably you've just twisted them around a tiny bit, so I'm just going to use my pliers to straighten them all. This one you can't get into much, but it's straight anyway. Those two you won't be able to get into at all. Now I'm going to straighten the board up. It's not sitting exactly flat because this dual gang pot throws it off a bit, so I'm lifting it all up and seeing that the levels are about the same. There we go, that looks about right. And now that it's in place, just start soldering. Now pots are fairly sensitive to heat, so if you're spending a lot of time you can move on to another one, come back to it. You gotta work out what will be the best angle of entry for you, have a fiddle. And be careful not to melt the capacitors. They shouldn't, but if you've got a plastic box cap, they melt pretty easily, the casings on them. So don't rush this. If you accidentally touch against the capacitor and melt it, you'll be pretty upset about it. So all the pots are soldered in. I'm going to do the DC connector wires now. So this is the negative. Like I said, that goes to the one that's sort of going off sideways from the other two. Let's solder them one at a time. And V positive goes to that one that's sort of at the top. I'll probably do this LED now. If you're not sure, sometimes I don't solder the LED until I've turned the circuit on, make sure it's all working, just for the off chance that you had to pull the circuit out again to debug something. But I'm fairly confident everything is going to be gravy. So what I'm going to do, I'm not going to stick it all the way out because there's a small chance one day in the future someone could push that and the legs could crimp it inside. So I'm just going to let it sit like almost flush, but at a point where you're not going to be able to jab it back in accidentally. Murphy's Law sort of thing. Don't drop any clippings in the bottom. Another advantage of that extra nut is if you drop stuff in the bottom, it's easy to get out, whereas if you had little clippings and you have debris fall in, it can really easily get stuck under pots, and then it shorts up against the metal to the audio and stuff, and it can be really tricky to debug. Okay, so now it's just the foot switch. What I'm going to do, start from the bottom left here, is put like a little bit of a gentle curve on and try to avoid putting a hard kink in it. So I'm going to curve it around and then back in and just feed it through and pull it through and leave the excess there for now. This one's got a bit of a solder blob on it, so it's a bit harder to get through, but all good. And this is so much easier than stripping all that insulation and maybe melting the insulation, bending it and snapping the wires. And now I'm not pulling on those terminals. The foot switch is probably the weakest point of the pedal. It's very easy to damage with heat, or at least the easiest part to damage with heat. It gets mechanical stress. I'm going to say this one here and this one here, where it's got the extra link, be really careful when you cut it not to cut that one at the bottom. So go real slow and make sure you're doing the right thing. Don't rush. So I'm just cutting off all the excess and making sure that they don't fall into the bottom. And they're ready to solder. That's a bit messy. Clean my iron tip off. Now these ones that have the extra link, make sure that the terminal is completely full and they got solder going clean to the link and to the other link. Like, it's very easy to make it look like there's enough solder and everything's connected, but it isn't the case, so just double check it. And again, I'm trying to be very quick with the foot switch. If you're heating up a pad, you feel like it's getting hot, you can wait a bit, move on to something else, come back to it. But working quickly should be fine. Okay, this out wire, I've just sort of bent 90 degrees backwards because I'm going to flip it over now and feed it into the center. I'm going to make sure that the wire is between these two terminals before I solder it because I don't want anything melting and touching. This is actually Teflon insulated wire, so it really can't melt. It's made out of the stuff your fry pan's made out of, you know. It's impervious to heat. Okay, we're on the home stretch for soldering. Oh, one thing I didn't get out. These are optional, and what they're going to do is make sure you've got a really good connection between the hardware and the enclosure wall. So you can do this however you want. You can put wires on if you'd like, and wires would actually help you to, if you had to pull the board out to debug or anything in the future, but because this is such a simple board, I'm not really banking on having to debug. So I'm going to feed this through, both sides. It's a bit fiddly. Now I'm putting on the 1/2" socket. You can use a shifter. If you're going to use a shifter on this, I would say do it sideways, not like this, because I've slipped so many times and you'll have a scratch in your paint or on your box. So what I mean is I would do it like that. Now my box has a tiny bit of slack in it, so I've got the option to really center it up with that little gap in the board. And I'm going to straighten it up so it looks neat. Hand tighten, that's fine. And do the same with the out. Just fiddle it around to where you want it. That was a lot easier than the in one. Again, I'm centering it all if you have the opportunity to twist it, make it look neat. Okay, now we've got 3 connections here. If there's excess, you can sort of fold it over, make it look like a mechanical wrap. Now I definitely wouldn't pull on these, like I don't want any stress between here and the board. If anything, I want a bit of slack. Especially if you ever want to pull this board out again, you'd have to loosen them up and they can pop out. But if it's really tight, you know, you never know if you're going to tighten it back up exactly the same way. So this way it's serviceable if you leave some slack. I'm going to cut these little excesses off, 3 of them. And these should be the last 3 solder joints, I think. Just clean little flux as I go. Now I'm going to use gravity on my side here because I'm flowing a lot of solder. If I flow it from underneath downwards, it's going to look a little neater. Oh, didn't fill the hole. I'm trying to heat the terminal here. This terminal goes to ground, so the enclosure is heat sinking it a bit, so it's a little bit of extra work if you've got a cheaper iron. So I'll just leave it there for a moment longer. That's my cleanup. I just flick the flux blobs and any little bits of metal. And that's all the soldering done. I'm going to move this aside just so it looks like it's nowhere near shorting, not that it is, but looks a bit more professional. Now to put the knobs on, I'm going to rotate them all as far as they'll go one way. You know how to put knobs on, but I'm doing it anyway. And back out the grub screws so they've got enough room to get on. I'm putting it so it's facing about 8 o'clock-ish. And I'm going to tighten it up so it's still got a bit of slack to move. So sometimes it takes a bit of trial and error to find that fine tuning. Just a little bit tight, not much. And then I'm going to set them all where they need to be. I've done thousands of these, so I can just eyeball them. Tighten it up the rest of the way. So I'm rotating it off just a little bit before I tighten it up. Congratulations. I mean, to me and to you, because hopefully you're building this. That wasn't that long. Now you might think, wow, Darren, you just built that pedal so quickly, how much are you charging for them? But don't forget that there's also the box is half the work. And most of my work actually isn't soldering. I'm really lucky if I can get 3-4 hours of soldering per day. It's mostly dealing with customers and running all the business ins and outs. Like, I wish it was all soldering. That would be so good. So thank you so much. Please let me know if you have any questions, because if you have feedback, then that helps produce anything in the future. I'd like to keep this going and share the love, like tell your friends, I don't know. Help me out. Cheers, guys. Thank you so much for building this and for having any interest in the circuit board and what's going on here.